So what is thermal decomposition? Well, we should know that decomposition is breaking something down. Should have come across this before. And if it's thermal, it's to do with heat. So if you put it together, thermal decomposition is breaking something down using heat. This is a typical diagram of a thermal decomposition experiment. So what we see here is a boiling tube containing our metal carbonate. There's a bung with a delivery tube attached, and you have a test tube that contains some lime water. Now we have to set the Bunsen burner on the blue flame, so we're heating strongly here. The carbonate will break down. Should change in color. Any gas that's formed will go through the delivery tube, down into the lime water, and bubble. Of all the carbonates that we use in our experiment in school, copper carbonate will decompose the quickest. Copper carbonate is green in color to start with, but when it breaks down into copper oxide, it will turn to a black powder. Another product is also formed in the decomposition. It's carbon dioxide gas. Through a delivery tube, this is bubbled into lime water. And when it's bubbled through lime water, it forms a milky precipitate. So the reactivity of these metal carbonates depends on the reactivity of the metal that's inside the carbonate. So if metal carbonates contain more reactive metals, their compounds are more stable, and it will take longer for them to break down. If we had less reactive metals like lead or copper in the carbonate, these will break down really quickly because the metal inside them is not as reactive. That means that the carbonate itself is unstable. Right, let's look at some equations to do with these. Okay, so the carbonates will always end in CO3. That's the carbonate group. Okay, when this breaks down, it will break down into copper oxide plus carbon dioxide. And if we try to balance this, it should all balance out. We've got one copper here and one here. One carbon here, one there. We have 3 oxygens in the carbonate. We have 1, 2, 3 oxygens in the products. So it all balances out perfectly. Okay? Every single one will balance the same way. So if I choose another one, let's say magnesium carbonate, what we should form here is MgO plus CO2. Okay? One final thing that we could add to these equations to guarantee us all the marks in any question is something called state symbols. Now the state symbols you should already know. We put a lowercase s in brackets if it's a solid, an Al if it's liquid, a Q if it's aqueous, something dissolved in water, and we put a G for gas. Okay, so we look at these substances now. We know that the magnesium carbonate was a powder, so it must be a solid. The magnesium oxide would also be a powder, just different color. This would also be a solid. For the carbon dioxide, we know it's a gas, so we put a lowercase g in brackets.